We want to look at how to solve the two different kinds of absolute value inequalities. And the main thing to look for when you're solving an absolute value inequality is the direction of the inequality symbol. So for our first example, let's look at the absolute value of 2x minus 2 is less than 4. When you're working with a less than sign, that means that the distance from 0 of this expression has to be less than 4 units. And so if you just think about a number line for a moment, it's just me thinking over here. Here's number 0, here's number 4. Where are we on the number line if we're less than 4 units away from 0? Well, we could be over here. All these numbers are less than 4 steps away from 0, but there's also some stuff over here that's less than 4 units away from 0, and that goes all the way down to the number -4. So when you get a less than absolute value inequality, you want to rewrite it without absolute value bars as -4 is less than 2x minus 2, which is less than 4. That's a way of saying that this expression here is between -4 and 4, because it is the expression that represents these solutions here between -4 and 4, since they're less than 4 units away from 0. So, key thing to remember here then is that if you have a less than symbol, you're going to end up dropping the absolute value bars and then rewriting the problem as a compound inequality, where you keep the 4 on the right side, but you also have to put the -4 on the left side, okay? And then when you solve that, you can solve it by just isolating x in the middle. So like I would add 2 in order to get rid of that -2, and when you add 2, you have to add it to all the spots, right? So that gives me -2 is less than 2x, which is less than 6. And then you have to divide by 2, so divide them all by 2, so you can get rid of that. And then you can get your final answer. 1 is less than x, which is less than 3. Okay, and then when you're finally putting your answer down on the paper, you might draw that on a number line. The final answers for x are actually ending up between 1 and 3 according to this. So here's 0, here's 1, here's 3. You're going to shade in the numbers between 1 and 3. And then because it's just less than and not less than or equal to, you use parentheses, which we can also write in interval notation. Since it's just one single interval, it's just 1, 3, and boom, you're done. Okay. Now let's look at the other case. Remember, this was what I would call the less than case, because the absolute value is less than the number. In the other case, you may have an absolute value inequality which is greater than a number, like the absolute value of x plus 2 is greater than 4. And in that case, we're saying that the distance from 0 of this expression is more than 4 units away. So we're more than 4 units away from 0. Well, when you think about that meaning, remember, just let's go back to the number line to think about it here. Where on the number line are you more than 4 units away from 0? And instead of being close to 0, that means you're far away. So we're talking about this section of the number line. Everybody over there is further away from 0 than 4 steps, and this section here, right? So we end up with kind of 2 separate pieces of number line. And so what happens is that you have to therefore write 2 separate inequalities in order to find those 2 pieces. So you're going to branch it down this time, drop the absolute value bars, and make x plus 2 greater than 4. That will cover this section of the number line. And then we also need to have a second one, which we can write as, x plus 2 is less than -4. And that covers this part of the number line over here. Those are the numbers that are less than -4. So see what happened is I flipped a sign to less than, but I also used -4. So I have to have two inequalities. One basically just matches the original problem, but the other one, it's flip the symbol, change the sign. Okay, now we're ready to solve these two. These are quick ones to solve, so let's minus 2. This one gives you x is greater than 2. This one that's minus 2. This one gives you x is less than negative 6. So the final graph of the inequalities, when you put it together, is going to have numbers that are greater than 2. So that would be over here. And you would use parentheses for that because it's just greater than. And then also numbers that are less than negative 6. So we're going to put negative 6 on here. And then the numbers that are less than negative 6 are over here. So that's your graph. But the issue was, how are you supposed to write the interval notation for this? Because we have two separate sections here. We can't just write them in a single interval. So we're going to have to write them as two separate intervals. And they're going to look like this section over here, which is everything from negative infinity to negative 6. And this one over here, which is everything from 2 to infinity. The problem is you can't just write your answer like that and then be done. You can't just answer that because it doesn't seem like it's all one answer. It looks like it's two separate answers. And even though all that stuff is the solution to the problem, we want somehow to connect them. And so we have a symbol to connect two separate pieces of the number line, which is the U symbol. And the U symbol stands for the word union. And in math, the word union means to take everything in the two sets and put them together. And so you do need to put that in, but it'll only happen in the cases where you had a greater than to begin with, because those are the only ones that lead to two separate pieces. So I hope that makes sense, but let me know if you have any questions.
Made with Doodlecast Pro.